This conference will now be recorded.
I'd like to welcome you to our fifth in the series of educational seminars on network design and utilization for security systems. Today, we're going to focus on Midspans, another equipment component. This type of product is often mistaken for network switches as used in our applications for both PoE and switching. This raises the question, why have a device that only focuses on PoE? Why do we need this? There are actually several products that range from increased PoE requirements that cannot be provided by network switches. In order to increase system reliability, we can separate both the PoE and the switching functions. So there are your two applications, the need for more PoE power and the need to separate PoE and switching functions. Next is the confusion over mid-range functions. Network switches provide their functions with a limited known range of easily recognizable functions. Midspans, on the other hand, their features can range from just providing PoE to several operational functions that provide protection, reliability, and messaging. The key point, our midspans can vary to a greater degree than network switches. For this reason, our focus uses Vigitron products only as examples for establishing criteria for determining needs. This last point is important, as the educational goal of these sessions is to provide the tools you need to evaluate and not only the need for a midspan, but the midspan itself. So let's get started. So today we're going to cover midspans, why use midspans, the pros and cons of midspans, and again, we'll be using Vigitron midspans to talk about special features. As we just stated, a common misconception about midspans is that they're actually network switches. They're really not. So as a result of that, even though midspans provide PoE, they don't extend distance or switch the inputs coming in. Therefore, when we talk about a connection between a network switch and the connected device, such as a camera, the main point is that the midspan exists within that distance of 328 feet, 100 meters. It can be placed anywhere within that environment of 328 feet, but it does not extend the distances. Vigitron, on the other hand, does offer a full range of extended midspans for both UTP and coax. And this does give you a capability of not only providing PoE power, but also extending the cables, the length determined by the need of power in the connected device. So again, a midspan does not have any network switching functions. If I have a 16-channel midspan, then I must reserve 16 channels of my network switch to connect the midspan. Each port of the midspan then is individually connected to the network switch. The important point about midspans are that they conform to 802.3 IEEE standards for PoE, and that includes all the safety features and the parameters that we previously spoke about during Seminar 2 when we covered PoE. When should I use a midspan? Well, there are actually many considerations. The first is I have a network switch, but it doesn't provide PoE for my cameras. Many of the standard network switches that are out there only go up to 30 watts a port. And as we're mostly familiar with, lots of cameras and devices these days in our security environment require more than 30 watts, i.e. a midspan, provided the midspan itself does provide more than 30 watts. If we're installing a new system or upgrading an existing one, the existing switch then may not have enough power to support the connected devices, or may not have enough power to support the connected devices if we're using it with extenders or other devices within the transmission environment. We also know that many IT directors favor certain switches. Cisco and HP are just two examples. These switches may not have the necessary PoE power to power 60-watt domes. More often they don't. But the IT department wants to maintain the Cisco switch or the HP or the particular switch that they have in that environment. In this case, the network switch can be overlaid with the midspan in order to provide the right power. Or in larger systems, we may want to increase system reliability by separating the PoE power from the network switch. And in this way, have two managed devices. So standard network switches, when we look at this, again, only provide power within the range of 15.4 watts to 30 watts. Here again, the midspan can provide the power up to 60 watts. Also, if you're using Vigitron midspans as an example, there are other types of features that could help. We spoke about how PoE operates in session number 2. We spoke about basically the idea that these devices that are connected to it, particularly IP PoE cameras, can draw more power than is capable of being provided by the port. And when that happens, according to the IEEE standard for PoE, there's the tendency of them shutting down and remaining offline. And this has to do with the amount of surge power that's required when we activate auxiliary features such as day, night, LED, PTZ, etc. Well, let's say your midspan can add certain features to your system, such as the ability of monitoring the line, and should surge power be required, provide that extra surge power, or if your camera does go offline, have the ability of automatically restarting it and providing PoE. So another example of using midspans is not only the ability of adding power to your system, but also adding conductivity and reliability features. So basically, when we look at it, there's a lot of things that can be added to the system without having to replace your network switch. One of the biggest problems that we have is what happens in a normal installation. And the best way of describing this is through an actual example that Vigitron faced. In one of our applications, a dealer quoted a 800 camera system in a casino. It happened to be an Indian casino. And the goal was to replace their analog cameras with IP PoE cameras. Approximately 600 of the channels went in without any problem whatsoever. 200 of the channels didn't work. Just so happens the cameras in this case were class 3. They required a source power of 15.4 watts and 12.95 watts at the camera location. In examining the cabling, it was learned that in these 200 channels, the coax cable was segmented, and in the middle of it was mini coax. Well, the mini coax increased the resistance greatly and didn't allow it to work. The casino did not want the cabling pulled. So what we were able to do was we were able to increase the amount of power and use a mode called force power. Now, if you've participated in any of these other seminars, you know that that term of force power could be called an injector. And we all know that we don't want to use injectors because injectors don't have the safety factor within the IEEE standards for PoE. And should there be a short, there's no way to turn the power off except by having the power source burn up or the connected device. However, using our programming within our midspans, we were able to increase the power from 15.4 watts to 30 watts, class 4 IEEE 802.3 AT, which increased the detection pulse voltage as well as the power, but we were able to put in a headroom signature so that if thermal runaway occurred, if shorts occurred, it would act within the parameters of the IEEE and shut down. So there's another factor where we can overcome installations. We spoke about the cable bend in one of the previous installations. We don't necessarily know the exact distance of a cable within a wall. We don't know the twists and turns of cabling within a wall. And all of that provides increased resistance to the flow, in particular of PoE. Well, a properly programmed, properly featured midspan can be used to provide the power that can overcome those installations without changing the cabling. So again, we're faced with many situations where we go in and there's the IT department has Cisco, they have HP, they have any sort of standard switch. And the problem here is not that they don't want to learn new programming or anything else, but they don't want another device on their system that has an IP address. Because the moment it has an IP address, it's hackable. They become responsible for it. So what we did within our Midspans was something very unusual. In a sense, we removed the IP address and we made the setup and monitoring of the unit through external Windows-based software. Now, you don't need the software to operate it, but you can actually set up the Midspan, install it within a system, and there's no way you can access it. And in this case, it meets the requirements of a lot of these IT directors, and they feel comfortable in installing it in the system. On the other hand, the operational software for our Midspans has grown throughout the years to provide many other services, such as the ability of reading 400 ports, the ability of having emails on it, not that it's an email server, but it can actually send emails and send alerts, and of course, configurations. So a midspan has many, many advantages over that of just a network switch itself. And the surprising thing is when you marry a midspan with a non-PoE switch, the cost of the system together is not that much greater than the cost of a PoE switch. Because in network switching, the most expensive component is actually the PoE component based on those abilities and the power supply. So let's take a look. We spoke about how do we overcome objections, and that's what midspans are really about. They're really overcoming objections. Objections that can be physical within the system itself to have the system work, or objections that are operational, such as those of IT directors that have a particular network switch. So we spoke about the need to isolate and not have the unit hacked, not have it accessed through an IP address. We can do that. We spoke about the ability of providing more power. Well, again, typical network switches provide only about 30 watts per port. Once again, in our session on PoE, we spoke about the need of surges, of overcoming surges, and we spoke about that these surges are usually rated at about 20%. So that if we have a class 4 camera, again, 30 watts at the source, if we needed to increase that by 20%, that would require that the port have 36 watts. Vigitron Midspans provide a minimum of 36 watts per port, ranging all the way up to 72 watts per port. We can handle high resistance cabling. So basically, if we do have a problem because of bends, twists, or anything else within the system that provides high level resistance, we can overcome that by using a programmable force power mode that maintains the safety elements that we usually find within the IEEE standard. Another feature is the ability of programming delays in the system. So if we have high surge startups such as PTZs that when they're powered up go to a 0 point position, we can prevent basically damage to the power supply through high surges. The whole idea is to prevent service calls. And so when we're establishing this criteria, One of the other features that we have is the ability of programming an IP address directly into the port of the switch itself. And this allows us to monitor the connected device. And should the connected device fail for any reason, should it go offline, it will automatically attempt to restart the device by applying PoE and reconnecting. So how will your Midspan communicate and check on the status alert if you have a problem? Does it provide SNMP or email services? And here's another point you may not realize, but network switches and typical midspans do not have individual fuse ports. And that means if there's a short on a particular port, the main protection is the main power supply, which would render the entire switch or midspan useless. Vigitron switches have thermal capacitive fusing, which means that in view of a short, the port will shut down, but because these are not, in a sense, physical fuses in the way we think of them, they don't require a replacement. So if the condition goes away and we're monitoring the port, we can automatically restart the port without any damage to the port itself, or more importantly, the entire midspan. By putting this in the front end, in front of the switch itself, which is the normal position as you've seen with midspans, we provide additional protection to the switch itself. So again, is your midspan just a simple part of the system? Okay. Is it just, or can it be a system on its own? Does it have the ability of monitoring more than the midspan itself? Can all ports be given individual locations and port names? Can we give them naming conventions so that in databases, when we see failures, when we want to see statuses, we can easily locate not only the device itself, but also the connected devices to all the individual ports. And we do that through our software, which, by the way, comes with the product free of charge. So this is an outline of our midspan models, both 8 and 16 channels, standard or with extended distance UTP or extended distance coaxes. Once again, we always like to emphasize just how individual systems are. And every single requirement that you have there yields an individual design. No two systems are the same. There is no cookie cutter approach. And that's why Vigitron has a design center. And this design center is staffed by real engineers using databases of over 9 years of collected material, working with major manufacturers in IP cameras, LED lighting, wireless systems, and access control. We don't evaluate the products to see that they work to their specifications. Rather, we evaluate the products and their interaction within the network. And that's how Vigitron has resulted in designing over 250 products in every single category of networking. And the importance here is that when we can provide you with a bill of materials, and we do so free of charge and without obligation, it avoids another key element of finger pointing, where if you're using elements from different manufacturers within a similar network and they don't work, everybody seems to blame everybody else. In this case, you have one design from one manufacturer that stands behind it. Our products are designed, tested, quality controlled in the United States with local design and service support from skilled, trained network engineers. And all of this comes down to the longest warranty in the industry because we are the manufacturer. And that's production lifetime plus 3 years, which means that even if a product goes end of life, we still provide you with a full 3-year warranty. Once again, we want to thank you for listening to this presentation and hope that you continue to listen to any of the presentations within this series. For more information, answer your questions, Design Center support, please contact us by emailing support@vigitron.com, or you can address individual questions to myself, Neil Heller, at the information that you see on your screen. We look forward to your future participation in these webinars.